On everybody, we're back. Sunday or Saturday. Um, another stream, another session. So I was just playing around with this stuff from yesterday, the Cool Zone stream. Kind of like flattened out or lowered the frequency of the noise, just to get a different, smoother form or whatever, like less busy or less complex. We'll get started here in a minute. It's the freaking weekend. Hello, hello, Mistaken Tuna, Steve GH. How's it going, everybody? You guys have been still doing the hulai. Saw your stuff, Jeff. The what was it? Apples or was it tomatoes in the boxes? The slow motion stuff. It was pretty cool. So I really was like windowing the light or whatever here, and just trying to get like a certain shaft of light hitting the stuff. Apples. Yeah, it was a really cool destruction kind of slow motion RBD stuff. You did the scanned fruit for the apples, like 3D scans. It was just a sphere. You just modeled it. Very basic. Just a sphere with a, you just like soft transform the top point down or something like that. Yeah, I think once you, if you have like 200 of them or however many you had, you don't need to spend a lot of time on individual ones or whatever. Yeah, so I'll just save this. We'll get started. You're going to be doing some RBD stuff. This kind of roughly talking about like the same question that Alex had in the Discord server. Just about like controlling an RBD simulation in a manner that it's reforming and aligning to the shape that it's trying to reconfigure into. So usually like the easiest way is to just break it, simulate it, and then play it back in reverse. But that has a certain motion to it that just, it looks like it's played in reverse. So I'm going to be just doing some overview or brief discussion about one way that we could simulate it, control the orientation of the pieces and rotations and stuff like that. Brando, how's it going? So my sand tutorial man. So this is that shattering, I don't know, not shattering, but like crumbling guy or whatever. Gamma Bassoon, how's it going? So I did the kind of animation simulation just using the motion capture guys from Houdini, like I did with that wind Hulai stream, where it's just you use the mocap biped object node and then you pull in the stuff, and then you can convert them into particles and do interesting kind of character-based effects. So I started to light it, play around with that stuff. I was doing the, you guys ever read this effects guide article? It's about this Piper. It was like a short that Pixar did, like one of the 3 or 4 minute things before the before one of their feature length movies. But one of the things they talked about was just doing a few different variations of shaders and different kind of little models for the rocks. So it's just little do like the mountain sop or something like that. Sasha, how's it going? It's pretty good here. It's a nice sunny weekend. Nice, pretty warm, typical kind of California weather, I'd say. So yeah, I'm still working on kind of lighting this. This is a bit flat or whatever. I might do like more rim lighting or something. But I'm hoping to get this tutorial done relatively quickly and then put it on YouTube. Hopefully get some more people in the community that way, like get some blogs reposting it or get it featured, passed around or stuff like that. So hopefully that will work well soon. Yeah, so let's get started with some RBD stuff. So we could just do like a sphere. I don't know. Maybe I'm just gonna set this up in a very basic manner. Kind of like just not even really caring about like the art, how good things work right now. Can you use mops in this challenge? I'm not doing a Hulai challenge right now. I'm just covering some topics and stuff like that of kind of RBD animation and stuff. I think you can use mops for the Hulai challenges though. Like I think they said all the third-party OTLs and Orbolt tools or wherever you get them. It's a little unclear with the rules because it's like you could you could make an OTL that's just like, or a Houdini digital asset that has like a model geometry in it, and then that's a workaround to do it. Like that's basically what these things are. It's just like a model that's in a container that gets distributed with Houdini or whatever. So it's like a bit unclear with their rules, but you could use mops if you're entering with it. I'm not going to be using it right now because I'm just more interested in covering like the low level concepts of things. I feel like mops is geared towards people coming over from Cinema, like Cinema 4D. So some people that already have like some RBD knowledge and stuff, it's a yeah, I think Henry did a lot of work and research and stuff like that into how to control the orientation and all that stuff. So do polylines, and then if I just do Voronoi split. This might be too many pieces. I think we're good. We might do a bit less. One thing you can also do, it's pretty cool, is like this points from volume. Watching some more like motion graphics stuff, and it looked like they were using some of these nodes to get like a lattice, like a repeating kind of form. So if I just do assemble, make packed and random for colors, you kind of visualize stuff. You just do the color to primitives. So if you do this points from volume, you can start to get like just box patterns or whatever. If we do interior surfaces, we just want to make sure our normals are looking right. So if we apply normals before the fracture, then the edges will look smooth. If I do exploded view, we just don't have normals inside of things now. So I can do another normal, but now this might mess up some of these edges. So we only want to do it to the new interior edges that were created. So if you look at the spreadsheet, there's this CLI PPT attribute. And basically, if this is -1, you can tell between inside and outside faces that way. So if I just do at CLI PPT equals -1, this is doing the wrong operation right now. It's doing only the outside. So if I just do exclamation point, then it's only doing the inside. So if I explode it again, then you can kind of see what's happening. Now we just have proper fractured, packed geometry ready to be simulated. So these things are just visualizations. You could just put them over here. And then we can just do a DOP network. We can do the packed. This stuff is a bit easier to set up, I think, because they have the first context, and then you just do the RBD solver, I believe. Wrong one. Rigid body. This is just the older solver, and then this one has the 3 different engines. It's a bit redundant that they've named it or whatever that way, but so this has a bullet solver built in, but then it just has these extra inputs, which make it a bit nicer to work with. So it's just super easy to just make forces and get started with things, because you can use all the particle kind of art direction forces, or any pop force you can use to control your RBD pieces. So if I do maybe this orbit speed, we can just rip apart this stuff kind of radially, or like a spin field or something like that. We could make our guide a bit bigger and introduce like some suction speed, or try to get stuff in like somewhat of an equilibrium. If you spin it too fast, it will follow, like fly away, fly off the stuff. If you find like a balance, it will kind of reach like a stable orbit. There's like the 2 forces, one is rotational, and then the other one's attracting stuff back towards the center of everything. So that's pretty cool. I think you can use the pop spin. And then this one, you can use it to control the rotations of things. So I'll just turn this off. For what I'm doing right now, I'm just working in a very technical manner, kind of trying to set stuff up, debug it, make sure it's doing what I expect, and then building stuff slowly like that. Sounds like I should get my scientist hat on. Yeah, I actually have a lab coat that like a scientist lab coat that DreamWorks gave me that I could put on. It's like kind of the scientific method of checking your results, making sure that you get what you expected or whatever. Working with DOPS, sometimes you turn into a scientist, or a mad scientist. So usually I use this axis relative to particles orientation. And then spin speed is just based on time, like how fast they're tumbling or rotating. So I think that this is like time in seconds, and then based off of degrees, like 0 to 360. So you generally need like bigger numbers to get them rotating. So that's pretty nice. Do you use your lab coat while it's handling Houdini? Not, I don't think I've ever really worn it since DreamWorks gave it out to me. But yeah, explode everything like a mad scientist. Yeah, there was actually a lab, like a challenge that we had to do with a little scientist lab, and there, like someone had, it's like a team project. Someone had to make like a Bunsen burner bubbling. There was like this sparking like Jacob's ladder thing that was like going off, and something like blew up, and that was like our first challenge as like new hires to do this lab sequence. So some of these, you can see they stop and slow down. It's a mystery why this is happening. So we still have spin speed, and we still have like this. There's no reason that this should be stopping to affect things. So we really need to crack out the Umair, you're not too late this time. We're just getting set up. So I've just Voronoi fractured this sphere into some basic kind of array of cubes, and then I'm just doing packed RBD, getting these pieces and setting some forces up. So we're going to be doing, so I'll get to that stopping in a second. Let's put on the lab coat for this one, so I'll get it. All right, are you guys ready for this? So this is fully emblazoned with the nice. This is like actually stitched, pretty nice. Like it's fully threaded, and they even popped my name on it. So we'll put this, get our coat on. I think it still has like the shipping container or the shipping. There's like a weird sticker or whatever. All right. So we're fully in the lab now. Is it multi-threaded? The what is that called? That stitching method. You must wear this all the time now. Only when I'm doing the deep debugging. But yeah, I forget what that needle, I don't know, that patchwork is called. Nice outfit. Yeah, it's like actually official. It has these little slits cut into it. So basically you could still access like your pants pockets and stuff, even when you have the lab coat on. It's like actually intended for real use. So the stuff is stopping because on this packed object, they have this feature turned on called enable sleeping. So this basically does some tries to do some detection to see if a piece has slowed down enough that it should kind of mark it as inactive or put it to sleep. So if you turn that off, then you can see we don't get any stopping. Basically, if this linear, which is just like positional movement, and angular, which is the rotational spin, go below these thresholds, it will mark it as asleep or inactive. You could play around with these if you want, but you can also just disable it. Like this solver might not always be, it's just sometimes a bit buggy with these, and like if you just want to make sure nothing is ever put to sleep, sometimes it's better to just disable that than should be disabled by default to be accurate. I think so. It's part of it's like an optimization. So if you have like a building falling apart, like the lower level crumbles and then those pieces stop moving, it's like an optimization to just treat those as static colliders. So it's can be a nice thing. Like I think you could see if I play this, it's pretty slow. And then if I turn that off, it gets even slower. Does that kind of see? I don't know. I'm not doing that well of like performance monitoring or whatever, but kind of should make sense. So if I get a spreadsheet for this DOP network, you can like manually tag things to be asleep or whatever and manage it yourself if you want. Basically, if you look at the geometry inside of the simulation, they have a ton of different attributes, but maybe if I start to play it, the solver adds some more attributes. So if you're really digging in deep, I think that they have this like Might be sleeping. Bullet underscore sleeping. So I have that setting enabled right now. If I just go to a frame where some of that stuff was stopping, you could see that this value is turning to 1. So it's telling it to kind of disable, and then it has this deactivation time that's basically how long it's been put to sleep for. I think you can modify that attribute and stuff yourself if you really want to. Some of that stuff on this Wrangle cheat sheet or whatever that I made, DOP packed RBD attributes. I think I listed it a little bit, just like the bullet sleeping tracks whether the object has been put to sleep by the solver. Deactivation time, amount of time that the speed has been below the linear or angular threshold. So I think like it's possible to manually adjust or change these attributes if you want, but it just gets into a bit of a... I just usually either enable it or disable it to fix things. So we'll leave it disabled right now. We can also work with this vex expression, like to change this axis. So if I just do axis equals sample direction uniform, and then I usually input this with another random and do it based off of the piece ID or particle ID. So this way, everything just gets a random direction that it wants to rotate around. You could also you just comment this out, and like you can manually type in different numbers. So that's a good way of controlling the rotation if you need to get a little bit more control than just this node right here. And you could also do a bunch of other attributes, like you could change this spin speed over time. Like if you want something to crumble, maybe it starts spinning and then just gradually slows down over time. So that's a nice one. And then this pop attract, maybe we'll start working with this. So what I'm going to try to do is start tackling or going into a problem or the kind of question that Alex had in the Discord, that was getting something to reconfigure or rebuild itself pretty much. So maybe just trying to think what the best way is. Use rotational stiffness in the RBD packed object. I don't use it too much. Sometimes I'll change a bit of these physical parameters, but sometimes I use it, but I don't know, it doesn't seem to be that accurate or that like user friendly to adjust. Doing the pop drag spin with spin resistance seems to be a bit better at controlling like that rotational stiffness or spin resistance. I don't know, it's kind of the same. I think it uses different mechanisms to do it, but you're kind of trying to do the same thing. So like if this, I don't know, it might be weird if they're really fighting against each other, but like we do this really random thing with a drag spin. This one, I think you usually just want to start with pretty low numbers. like at a certain point, it should just calm things down a bit more. Yeah, it's a rotational stiffness with bullet. At least, just I think it doesn't. It's just not super stable or predictable. I guess it's a bit, I don't know, buggy or something like that. So drag, spin, and drag are good ways of just adding kind of stiffness or like positional or rotational stiffness to the simulation. And then as well, you have this speed limit. And this one's a bit tricky because you can do spin. You can set the maximum and minimum rate at which things are rotating with it as well. So this is a useful one for sometimes at the end of bullet simulations, you have like little butterfly pieces that are spinning around like crazy fast and they just look fake. So this way you can you clamp the rotational speed, which is nice. So I'm just going to maybe use this activation and just do $SF equals 1. This is saying this when the simulation frame is equal to 1, apply the force, or it's basically doing it instantaneously, like only on the first start frame of the simulation. And I think on this guy it's a bit tricky, but I just need to solve on creation frame. Otherwise the solver like hasn't started solving when this stuff is trying to apply the forces yet. And then if I'm just doing it like once, you just want more strength in your forces. So we just have I don't know, a basic kind of explosion, I don't know, some kind of slow motion thing happening. And then this is our source geometry. It's plugged into the first index 0 or primary input. We want things to start going back to their source position. Like you can use this pop attract, but one of the issues is that it's just using this global centroid or the origin of the scene to pull things towards that. So if I set it to positive 2.3, everything's going to seek to this, and it kind of overshoots it and rocks back and forth a little bit. So it will never really get to where it needs to go, or it will just always like bounce back and forth kind of like that. So it's a bit difficult to control. If I try to just jack the force up, you might be able to get it to like stabilize where you want it to a bit more quickly, but it's still very bouncy and not that useful. I've tried like these reversal distances and stuff before, but they don't seem to work that well either to kind of like predict. There's also this follow that has like predict intercept and stuff on, but all of these things I've just never found to be that helpful for getting stuff to like go to a position and stop there. And like if we're trying to get this to reassemble, that's the kind of behavior that we need to do. So what we can do instead, just gonna bring that back to defaults. So I think with goal, what I can do is maybe use points. I think I can use this first context geometry that's just saying the same geometry like that we're using as our source. So we've set it to the first context or the primary input of our DOP network. And then with this pop attract, we're saying instead of manually just typing in one goal coordinate globally, use the point positions of that same source geometry. And then match method, I think instead of average position, you just want to do point per particle. We could kind of do that as a quick test, and then you can see it's just a bit more precise. It's still having the issue of shaking back and forth, but overall it's a bit better to kind of achieve what the positions are more accurate, because each one is trying to match its original position instead of a global centroid. It's a good dance move. Yeah, it's like it's a fat guy kind of shaking his belly around or something like that. Yeah, it even gets, it seems like it's getting more interesting. So over time. So if we want to fix that kind of issue, what I would do is start to add drag. So when you pull something towards a position, the more drag or resistance that you apply, then the easier it is for things to kind of achieve like an equilibrium, or to stop at the destination that they're traveling to. So this kind of depends like how controlled you want it to be. So I have this force scale pushing things back to their original position at 15 units. And then this resistance happening at 25 units. So I might just want to, I'm just going to add some animation to this stuff. We'll just go from 1 to frame 72, like 3 seconds in. And then I'll also just turn on that clock icon for like real-time playback. So I want 25 and at the start just 0, no air resistance. So if I shift click on that, we can see the keyframe, we're just easing into more air resistance over time. And I can do the same thing with this. So at the start of our simulation, we don't want any attraction force. And then at frame 72, let's go up to 15. We might want to change these values later. If you know you're going to be just modifying like a few values, you can just click the pin over here. And then when I, where did it go? Here it is. When I bring the animation editor back open, you can see that parameter. And just do always on top if you want it hanging around a bit more as well. So those are our two forces. We're back kind of in the scientific lab with our oscilloscope measuring waves and frequencies and stuff. So you can see now we visualize our strengths. So we're able to control this stuff a bit better. So you might want maybe, like if I reverse this suction speed, it will, at the start, the kind of impact, it's going to blast it away a little bit more strongly. Could also change our interpolation of these functions so that we're doing more of like a power or exponential kind of increase. Vegan Nuts, how's it going? So we're starting to get a little deep into the lab here with some RBD, controlling them, art directing them, or really having tools to manipulate a lot of aspects and stuff of them. So I'm trying to do like a reassemble type of effect. The first frame, we just have these forces happening. We have a spin, so each piece is getting randomly forced about its axis, or a random axis. and then this pop force is kind of flinging them outwards and around as well. I don't know, this orbit. There it is. Pow. And then I have a few different... Where did it go? Did I lose my animation editor? I have a few different animation curves that are starting to pull everything back to its input positions. So with the pop attract node, I have it using the point position of the source geometry, the first context geometry, and it's just matching it, each point by its original point number, point ID. So it looks like it's working. We've got everything shooting apart and then somewhat slowly coming back. We might want to add some drag spin, just kind of like the rotational stiffness, just to get that stuff behaving a little bit more calm. We don't have any forces or anything telling it right now how to match its input rotation or alignment, so that's why they're a bit off. And then I did go up to 45 here with this for attraction strength. So you can see we have him dancing around again. So usually we just need to compensate that with air resistance. So I don't know how high we need to go, but definitely higher than the value we were at before. Very nice, no background music, deep in the creation. Yeah, I don't know, I figured because this is a technical, I don't know, informational stream or something like that. I was take a break from the music today. Because also I was looking at yesterday's stream and I had it like a bit too loud. I don't know, it might have been a little distracting. So we have it behaving a little bit better now. If you really need to at the end, like you can deaccelerate or ramp down this attraction force to really get, like, remove some of that last jiggling or things like that. But it's just a balance between the main air resistance and then the attraction force to make sure that it doesn't pendulum around forever. Then you can see that there's stuff happening here where, like, it's harder for these pieces to you thought something is different. The music, yeah. Yeah, so you could play your own music today if you want, if you really want to party or if it helps you focus. So we get this so you get this issue now. Things are really still having some trouble, like, finding their final position. It's kind of an issue where, like, it's never really going to be 100% possible for these to fully find their original positions because they're colliding with each other. So, like, if you really want to reassemble something in a more, like, elegant fashion so that it's not, you're like, this is like a Rubik's Cube that you can't solve or something, right, like that, or like you're trying to assemble Legos that don't snap together and you're just like mashing them together. So if you want to play around with that, Bullet does have this collision ignore string attribute that you can use to see what's colliding with other stuff. So I think if I just do pop wrangle, geometry wrangle, they're pretty much the same thing. This is looking for a string attribute. That's why there's the S at the start. If you just set it with these two quotes to like an empty string, stuff is still colliding, and we just need to put it into a group. Otherwise, it doesn't have a group name, so it matches this. So I'm saying this group might just be the main, kind of like a layer, or like if you want to have certain things colliding with others and not other things, you should be able to do it with this. There's been a recurrent issue with other software too, like Maya, Mesh, Cinema 4D. Always been delicate to bring all the pieces back to their first position. Yes, I think there's some MOPS tools that might be useful for that. I'm just going through kind of the low-level laboratory approach today, kind of going deeper into the concepts or the attributes and technical areas of stuff. So to hopefully, like, you could break down certain areas and apply it to other effects or other parts of your workflow. So I think something's wrong with these attributes that I've set here. We have a collision group, collision ignore. Oh, so I've just messed this up a little bit. My collision ignore should be the same as my group. So you could see it's already like a bit more chaotic. These guys are allowed to move freely, and they're just completely ignoring each other. I think you can change stuff. I don't know, that might be the only way to disable collisions as well. I thought that there was like a global toggle somewhere, but it might just be setting these attributes like this. You use extract transform to calculate a difference between initial and current state. Yeah, that can be useful. The extract transform node is super useful. I don't know if I'm going to be using it for this, but it's a really nice one. There's also a way you could just do an asterisk for this. And then this way you can say ignore any group. You might even be possible. Like, then I don't need this earlier group name. I could just say basically you're ignoring everything in the simulation. And it seems a bit weird at the start. So because this is point attributes, like you can set this to things over time. It's not like a global toggle. We have per piece control over things. And we also just have this activation. So like maybe when the frame is greater than 48, then ignore collisions. So everything starts to kind of look the same, but then they're able to get to their final position. So if I just look at like wireframe, or I don't know if there's a way to just do, maybe if I go back to my shaded view, if you just do packed edit, then you can change the way that these are displayed. So I can just visualize the centroid points of things. You could see we've pretty much solved the first task. Like, I'm breaking this down into 2 steps. The first task, or the first problem I'm trying to solve, is the positional reassembly. So our position attribute or alignment is pretty much solved. Like I was saying, if we really wanted to finesse this and change values and stuff, we could get these things locked in a bit more. I'm just going to ignore it for right now. Yeah. So let's try to do the rotation stuff now. I'm just gonna save this before anything really bad happens, or we solved something, so let's save the progress. Do 2020 July 11th. Do a new scenes, and this will be RBD assemble. Yeah. So we want to get these to reassemble. Let's just get this spreadsheet back out. Again, we can look at the geometry, and there's like a ton of attributes, but I think using this orient, this is one way to control the rotation of things. With stuff being packed geometry, there's also these transform intrinsics that are a bit more complex because these are like matrices. They will store the rotation and scaling of information, but the orient is usually a bit easier to modify. It is a quaternion, which is a bit of an unfamiliar way for most people to think about rotations. Usually you think about rotations with like 0 to 360 degrees for X, Y, and Z. But then there's radians, which are like based off of a unit circle or uses pi. And then there's quaternions, which are like imaginary numbers, or a bit, they use more abstract ways to represent rotations, but for reasons of like low-level computer graphics, they tend to be more stable. It's easier to do a blend of rotation from one kind of state to another with these, without like weird hitches and stuff like that. So this is kind of the preferred method for computer graphics. So just the nature of Houdini being technical and stuff like that is, unfortunately, you kind of do have to work with these sometimes. So one thing we can try in our code right here, we could try it like, they also have this top look at. You might be able to do it with this just being like a high level method of not having to deal with the orient. I'm gonna see if I can get it to work this way. So what I'm trying to do here is just leave it with the default stuff. I might need to do like spin. This is going to apply, like torque is kind of like a rotation. It's like if torque is kind of like if you grab the handle of a pan or a pot and you use it to rotate it. That's kind of like what the torque scale is just like how much force you're rotating things around with. I don't know if you want to do like treat as wind. This way we're kind of doing the two, attraction is like torque scale kind of, and spin resistance is kind of like drag. So this way we're able to get it back to its default states, kind of like the same method that we were doing earlier. This is super nice, being able to use these somewhat like high level tools. We don't have to deal with that orient attribute, I think, or even transformation matrices. We didn't go too deep into the lab for right now. Nice collar today. Thank you. Yes, I have this lab coat from this when I was working at DreamWorks, they had given it to me that was like this personalized, very scientific method laboratory coat. I put it on, cracked it out. We were getting pretty technical for a little bit. Yeah, it's pretty nice. There's this one SIGGRAPH where side effects, when I was interning there, all side effects had all the people at their booth wearing lab coats. It was like the Houdini. I think they were launching like Houdini Labs or a different version of Houdini Labs, like not the one that they just did recently. That was like the Game Tools shelf stuff, but this was like around the time that they were rolling out Houdini Engine, I think, and they were calling it Houdini Labs or something at the start. But they had all their interns wearing lab coats, and I found one of the like triple XL ones from was intended for like a pretty large person. I was just wearing that the whole time, like it was like a wizard's cape or like a wizard's cloak or something like that. So using this attract, basically I've just set this up with default settings. Like I think this Z just means like unchanged essentially. That's how I'm reading it. If I change this to this other direction, positive Y, then you can see we're reassembling stuff, but it's with a skew where it's like everything's rotated 90 degrees. But you could do it that way if you want, but it's not super necessary, or I don't know, it's for other, could be for other effects or something. For this, we just leave everything default. And again, with these, we might want to do like the same animation, depending, like, just depends how realistic you want this rotation and stuff to be. You might, I don't know if these values again are just like a little bit too high. It's kind of like a fight between things, like you want stuff to look a bit natural, but then you also don't want it to seem uncontrollable, like too chaotic, I guess. Like you want it to appear kind of like a reassembly or something like that. Like a very, I don't know, you want it to look like intentional, but you don't want it to look too contrived or too perfect, I guess, is kind of the way I'm thinking of it. We could also do another force. So you could try this as maybe like a wind, just like an ambient thing kind of pushing stuff around. Now imagine doing this on a modeled city. That would be sick. Yeah, using this for all kinds of things. Even starting with like pieces already laid out, like just debris laying on the ground, and then that could assemble into like the crag, the aggro crag. Like you could bust this guy into pieces, little rocks laying around, and he could get up and reassemble himself in like that kind of way. Doing it with motion graphics kind of stuff is kind of like I'm doing here is kind of cool. I'm just setting this up because it's a simple way to visualize stuff. But like basically I'm trying to verify that these tools are working before. Sometimes if you start with like a super complex thing, like I had a whole house that I'm trying to assemble with wood splinters and different materials, different constraints, and just a bunch of different stuff in the mix is just going to be too slow and too cumbersome to troubleshoot. So this kind of way is a bit just when you're doing R&D or doing new techniques, it can be nice to kind of strip everything out for a little bit. So I might go into this pop drag and we're ending on frame 72. Might want to go kind of doubled it just to try to get rid of that jiggle at the end. And then we could go up to the top level here. Sometimes this visualization is nice. So it's pretty cool. So this has some issues. We're never clearly assembling. One thing, just save it again. One thing that I would start to do if I wanted to perfect this even more, I'm just going to get rid of this disable pop attract, disable pop drag. This pops drag spin, I don't think I need it anymore because this, we're setting spin resistance in a different place. I think that's, I don't know if these add to combine, like they work together kind of to, but basically I'm keeping my realignment node. This is just disable collisions, realign to original. Maybe put this one down here. So that should be good. So I'm just gonna double click on this pop attract real quick. If you look here, you could see that they're basically just setting force as the output variable that they're using to kind of tell this what direction for things to go in. So if I do a pop wrangle, I can start to modify things this way. So data bindings or inputs, I can use this to get the first context geometry. I usually set that to input 2. Sometimes with this one you want it to be myself or like its own data. So that's why it's a bit weird. Sometimes people see like first context but input 2, but that's the reason to do that. So if I just do something kind of silly here, like if I do position equals points, get a point attribute from this. It's a bit confusing because these numbers here start at 0, these start at 1, but this is saying from the auxiliary 1 input, like 0 would be the first one. Point position, and you could just get it based off of the current point number, so we should match things by the point number. So again, just to verify that things are working properly or whatever, this one I'm just setting the point position to that source point position. Take a look here. Might be getting myself into a mess. There's also the we might have to take this into account. That's the pivot position. So I might need to like subtract pivot from this. This, now they're going completely to the center of everything. I might need to get the pivot from the first me let me see. So I think it was just the order of operations. If we just set that using this post solve input, basically then this operation happens after the RBD simulation cooks or evaluates. So you're able to just mash it or force it into that value a little bit. It's more of a brute force method or whatever, like you're directly overwriting the value after the simulation. I'm not 100% why they still move. Like, it might be it looks like they're stopping at a certain time. There might be some other forces and stuff like that that are changing things. But it is like calming down a bit more quickly. I don't know if there's more. It looks like this is the very last step. It might be because like the pivot or other elements that change the position of things move around. I don't know. This is just a guess, but we could try it with forcing the pivot to be a certain position. Looks like we still have that issue. We could try doing like velocity is 0, force is 0, and see if this. It looks like there's still some stuff happening. So I'm not 100% sure why that would happen. Yeah, there's stopped and active and stuff like that that I can use. I'm not 100% trying to like get this to is this 0? I was more just interested to evaluate if the position, like if we were getting the actual coordinate. So I think stopped equals 0. It might need to be 1. Maybe it's like 4. You could always do maybe active to 0. So I think with active at 0, then you're saying the solver completely ignore them. Treat it like a static object, and don't move it around. So you could also change that. Having this set to static is the same thing as setting the active point attribute to 0. There's some extra states here that you can use, but we're not going to get into them right now. So I think active, I guess stopped is just for particles or grains or stuff like that. But the RBD solver, I think, uses this special one. So that's pretty cool. We got it working. Maybe we'll just do vector target position equals the source geometry's input point position. And then if I make something into the color, stopped working flip. Yeah, I think flip is using a particle solver inside of it. And then they've also done some other stuff with it. But I think like right here they have this pop solver. So this will pick up, knows to work with stopped and stuff like that. This one in here doesn't have a pop solver. They've kind of gone in and like hacked around to get it to support the same attributes. But because it's like their implementation, it's not. There's RBD auto freeze and other stuff. Yeah, yeah. I'm not going to get too deep into that, but there's other ways to do that kind of stuff. So using the color, what I'm going to do is look at the distance of the target position. You just do two arguments with this. You give it 2 positions, and it will give you the distance between those two 3D positions. So we're no longer using this to modify any position, rotation attributes. We're strictly just using this now as a visualization method to look at the distance. I guess it's just easier to visualize. Like this centroid one doesn't show up. You could do add, delete geometry and keep points. And then this way it should show this. But basically this value, if they're at their destination, the color will be 0. The further they get, the brighter the color gets. It goes above 1. Like if I change my viewport exposure, you can see that these numbers are even getting bigger than white or brighter than 1. So it's just a visualization. One thing we could do is remap that just using this fit function. So this will start maybe at like 0.25, and then the maximum maybe we'll do like 1.75, and then I'm gonna do, when it's within this radius, change it to 1, and when it's further than 1.75 meters away, change the color to 0. So we're kind of squishing the range down and flipping it around. So this way things are eventually turning black, but now you can see we have this other positional mask. Maybe we want stuff to be a bit different, but we could do that to just see, get a black and white value of how close things are to their target positions. So that's nice. So we can just use that color visualization now to modify things, I believe. It depends. You could set a bunch of code up inside of here. I'm just going to try to do it using color. So if I change this force scale, just 1 is the default. Now I can override it using vexpressions and use that color value. So the force scale, maybe we want it to, this is when it's going to seek its target source or input point positions. So maybe we want to do 15 again. And if I just hover over this, you can see the parameter's actual name is force scale with no spaces. I can just do force scale. And I think what I'm interested in doing is plus equals. So this is going to add the color value to it. And then this color is a vector. You just do cd.x. You could do, this is saying the first component, oh, not that. You can do cd.r to say it. The red channel is the same, you're getting the same information as x. There's a different way to write the code. You can also just do, there's a function that's luminance. that will just retrieve the brightness of the stuff. If you're doing grayscale, like X, Y, Z, RGB will all be the same value. Luminance, you can do it as well, and I don't know, it might just be more straightforward for people to read. They're just saying, oh, you're getting the brightness of the color. So this way, when things get closer to their final position, we'll inject or add more force. I can even multiply this by like 25 or something like that. So generally it will be attracting back to where it wants to go at 15, and then when it gets within this radius or very close to its final position, it's going to really start ramping up to its final target position. Whoa. So it's working. And then we get the instability. It does the dance kind of thing. If I want to, I can just do attribute rename and turn off color, just to visualize stuff again. So this way we're just able, instead of like a global expression ramp that we apply to stuff, we're able like per point to say, once you start to get close to your final position, really just like snap into place. But you could see we introduced a lot of instabilities and issues when we did that. So if we do the same kind of idea with drag, we should be able to stabilize this effect, but still have that kind of ramp happening. So this one I was generally just doing a higher number than pop attract, just because I wanted to like push back harder than the attraction is happening to dampen it. Vex expressions again. So this time we're doing air resist instead of force scale, but I can just reuse this and then just highlight it, do air resist. So we're way too strong overall, such that it can't even get away at the start. So might want to getting like a bit of a jellyfish. Might want to change. All right. So what we're going to do is get our activation value back out, like by using it. Basically, we're disabling collisions after frame 48. I'm going to do the same idea. We're only going to start reassembling or applying our reassembly forces until after frame 48. Maybe it's a bit more clear to see them. So now it should be a bit easier to see what's going on. I think my pop attract, like this is the baseline attraction force. I think I want it a bit stronger. So you could see it just switched. Frame 48, boom, everything starts reassembling. And then I can just control this stuff a bit easier. This air resist, maybe I want it to go super strong. Looks like that was a bit too high. Sometimes with too much, you can cause stuff to kind of explode or that kind of stuff. So it's working a little bit better, just for things generally, I don't know, being more interesting. I'm going to just increase this starting time for when these forces kick in. instead of starting at frame 48, we'll just start at frame 18. And then I think my drag force, like I'm going to set that quite low, in the same idea maybe with that pop attract. Just kind of rebalancing stuff right now, trying to get it to look a little bit more more natural or interesting. My drag resistance is quite high. I'm just having to ramp both of this stuff up. So we're getting pretty close. And then the last thing that I might do is like a final touch or finishing thing is introduce this active at 0. So this is basically saying to the RBD solver, ignore, don't update, don't apply forces to this. But instead of setting this to 0, I might only want it to be 0 when the color, I could just do .r, I could do luminance again or whatever. When this is, when it's less than 0.25, then it will be 1. Active will be true. So it looks like this stuff here, we just don't want it to happen right away. So again, after frame 18, so we're deactivating things once they get above this value. You could, maybe it's easier to think about this as like, we'll just reuse this distance to the target, and when it's greater than 0.01 units, it will be active. So now we're freezing stuff a bit easier. And then the final step that we can do is just mix or blend this position with the target position. So if we take position, you can use this lerp function. This is just a linear interpolation or linear mix. So you could say go between the current position and the target position, and then the last argument or the last number is called a bias, where it's basically when it's 0, it will 100% just use the current position, and when it's 1, it will 100% use the target position, and anything in between, it will do a interpolation or a mixture average, a weighted average of the two positions. And then this one, you might want to use this color function. Maybe the red channel of it. Again, just like making it a float value, and I might just multiply it by 0.05. So a very, very small number. So it looks like these are more closely matching their final positions. They're getting locked into place a bit easier, but our spin and rotation is just not kicking in quick enough or strong enough. So I might make those numbers a bit higher. Might need maybe this to be a bit higher. So we could do that. I don't know 100% if I'm doing the right things. I'm gonna try to do a similar thing with the orient. So instead of being a vector, this is a quaternion, so it uses p just as the type indicator. And then instead of lerp, they have this slurp. Slurpy day. This is 7-Eleven. This is the Slurpy day. So we'll do slurp and go between the current orientation. And then I think if I do set like that, I believe that this is like a default orientation, or removing, basically saying don't, just go to the default position, rotation. So maybe I did something wrong. It's also possible that this orient doesn't actually like get affected by anything. It might just be like the solver needs to update it. So if I deactivate it, it doesn't apply to stuff anymore. So that's where I would need to start using maybe the primitive intrinsics or that kind of stuff. Basically what I'm doing is similar to like a post process, and saying after the simulation, go meet your final position, to really lock it in or solidify stuff in place. Loop between rest and current position. I think that's kind of what I'm doing. So this P should be the current point position, and the target should be this input or rest position up here. So I think we could check it with this. I think the positions are pretty close. Oh, with the rest node? Yeah, that was one thing I was thinking about, was doing these final adjustments, kind of like sealing things in after the fact. So there's a few different options. We have this mask here, which is quite nice. So this is already giving us a kind of 0 to 1 number that we could use with a lerp function or any kind of mix like that. Let me think what the best. You can do. Yeah, I guess you could do that. So that would require unpacking things. So basically, with this rests, store this source point positions before we pack the geometry. So once you pack it, you don't really have access to the to that point position. So just after the fact, we can unpack it, and then we can modify the positions again. I'm just going to want to transfer. I think I need to promote the color to a point attribute so that I can transfer it. Maybe I guess it's already a point. Let me see if this, maybe it just didn't want to show up in that list. But now we have it transferred over from the packed geometry. And then, yeah, I think we can, that was actually, I wasn't thinking clearly at first. But yeah, so we can do P equals lerp the current position, the simulated position, with the rest destination or target position, and then using the color, one component of the color value. So that way you can see things snapped into place. If I do a rename, just get rid of the color. So it looks like maybe this one, again, we would just want to only do it if the frame number is greater than 48. To make sure it doesn't change the start of the simulation. So it looks like some of that stuff got, we got close. Some of this, some of the rotations are too far off. This is a gem, it's 90% of a gem. It might just be like these forces here are a bit too dramatic. Maybe if I just scale this stuff back a bit. See what happens here. Ah, we got it kind of close. So it still looks a bit fake. I don't know, like returning back, but it's starting to be nicer. We could save this as a new version. There's probably some more elegant ways of approaching this. I'm just going to get rid of some of the stuff I wasn't using. This might have been an issue as well, that I was like constantly injecting turbulence or a random force into the stuff. So we have return to current position, drag to resist to provide a resistance. We have our kind of rotational stiffness, collisions that get disabled after a certain frame, and then this pop look at to realign just with a default, return to its default orientation, basically. And then this is a bit of a, I don't know, it'd be nice to not use this P position stuff. Maybe turn that off. We might not need it. It looks like it is helping just ease any popping. Did it work? So I think this number might want it lower, and then I think this, I might want it to be actually 0. Let's see if this, I might change, oof. We might, instead of this being popped on or off, I think I just need to kind of ease this lerp function in over time. So if I just multiply this by kind of a mask, like between frame 48 and 60, slowly ease in this lerp operation. You might be able to do it over a couple frames, basically like That's that pop that you see right there. So doing it gradually over a few frames, you don't notice it visually or whatever. So it's pretty cool. We could try this with other shapes. Maybe a box. It kind of works. I don't know what's going on with these normals or whatever. Do you think we need to recalculate them? I don't know. It seems a bit of a hack, but for whatever reason, redoing the normals helps. So that's nice. It could be cool to maybe instead of this axis and top spin, I still want to just do it as like an instantaneous force, but maybe we'll just do like this pop force with the noise. Maybe it needs to be really strong. So I'm gonna switch my method for doing this. I'm just gonna do it when the frame is less than 20. Maybe 42. It's getting, it's reassembling too quickly. It's like reassembling before my other hard. It's kind of a bad idea to like do these hard-coded start and stop times or whatever. Like, where was it? The disable collisions after a certain frame. I don't know, that's a bit sloppy. We could do this based on the color, like the distance threshold if we wanted to, but for right now, this is should be okay as a first pass. And then I'm just gonna change my point separation here to get a lot more pieces with our fracture. So now we have a more interesting complex animation or whatever. That's why I switched to the noise or whatever, just to get like a more interesting cohesive kind of shape. Still have something was going on inside of it. I don't know what. But this way we're able to more cleanly or seamlessly like reassemble or reconfigure, realign geometry in a somewhat clean manner. Sometimes with this points from volume, you do a scale in one direction, like if I just make it stick out like that, then I can get non-square shapes, like they're squashed or whatever. So this can be cool because then you can get like a bunch of little stacked flat kind of objects. So it's a bit slow to make them all, but let's see what happens. Whoa, blew up. Sometimes this is a pretty nice frame. Just keep it. Final, we're done. we made a picture. So I think some of the really small pieces can tend to like wig out a little bit. I'm just gonna go a bit higher there, and just change my scaling around a little bit. It looks like that we got rid of like the corner pieces or whatever. That's pretty cool. We just did reconfigure our data, put it back together. So we could delay it, maybe. Like if the reassembly doesn't start happening until frame 38. Might just want to do less force at the start. And we can get rid of, like if we're going slower, we just need to rebalance our forces, kind of. It's pretty cool. So I'll just save this again. It's probably gonna be it for today. Just handling more of a technical techniques or tool set. I don't know if this is the best method to do it, but it seems like it's a pretty, like, there's not a ton of vex or intrinsics or orientation, like low-level stuff you need to mess about with. Yeah, it's a good brief vex. Like I've done this before using the primitive intrinsics and like matrices, and perhaps I went too deep. So I think, I don't know, this is a bit nicer. Like if you really want the simple 1 or 2 node approach, like MOPS is probably the way to go. But just breaking some of this stuff down, like maybe certain elements of this techniques are more useful than others. So yeah, that's probably gonna be it for today. Got in the lab for 2 hours or hour and a half or whatever. No music, just hard work, banging it out. I appreciate everyone for sticking through it. Well, you guys had some good help at the end with that this lerp to rest thing. I think this is a really nice way to polish it, cleanly seal everything back together or whatever. Hang out with the lab coat. Yeah, so that's gonna be it. I'll upload this to YouTube. It should be a nice clear thing for people to be able to follow without music. Hopefully I'll finish that grain. This grain, I don't know. I think it's still been writing out a simulation cache that's pretty high res this whole time. But yeah, if anyone has a spare Amazon Prime, Twitch, you could link it to Twitch and use it to subscribe. Helps support this kind of learning process, limited hangouts, materials, and that kind of stuff. If you have money to spare, the gift, a sub or anything like that helps. I'm thinking this, yeah, we have the best emotes, we have the Kim emote, we have the gem emote. So you get access to that if you subscribe. It's nice. But yeah, other than that, I'll plan to see everyone tomorrow. Take it easy.